Hi, everyone, and thank you for joining us today for this webinar on demystifying data ops, riding the change. My name is Priyanka, and I work as an event marketing specialist at Hivo. I will be your moderator for this webinar. Before we start today's session, I would like to remind you of a few things. All attendees will be on listen only mode. You can type in your questions anytime during the webinar in the Q&A window that's available on your screen, and we will address them at the end of the session. So I'm sure most of you have already know about Hivo, but as we have a lot of new attendees, I will give you a quick overview. Hivo is a no-code data pipeline platform that connects and loads your data that is lying across multiple sources into a data warehouse of your choice, such as Redshift, BigQuery, Snowflake, and others. Hivo provides pre-built integrations with over 100 different data sources and also supports advanced data transformation. Hivo is currently used by thousands of data enthusiasts who are working across multiple verticals and who are based in over 40 countries. For more information, you can check our website www.hivodata.com. I will now introduce you to our speaker for today's session. Christopher Berg is the CEO and head chef at Data Kitchen. Chris has more than 30 years of research, software engineering, data analytics, and executive management experience. At various points in his career, he has been a COO, CTO, VP, and Director of Engineering. Chris is a recognized expert on DataOps. He is the co-author of the DataOps Manifesto, the DataOps Cookbook, and recipes for DataOps success, as well as an instructor for the fundamentals of DataOps. He is also a speaker on DataOps at many industry conferences and with other media outlets. Chris began his career at the MIT's London Laboratory and NASA Ames Research Center. There, he created software and algorithms that provided aircraft arrival optimization at several major airports in the United States. Chris holds an MS from Columbia University and a BS from the University of Wisconsin-Madison and served as a Peace Corps volunteer math teacher in Botswana, Africa. It's nice to have you here, Chris. Thank you so much for joining us. So,
Thank
Chris,
you.
let's begin the session. The virtual stage is all yours.
All right. Well, thank you for that great introduction. And so what we're going to talk about is kind of an introduction to DataOps. And to do that, I'm going to talk a little bit about myself as a way to do it. And with that great introduction, I think a simple way to say is I was a software guy for 15 years. I managed teams and wrote a lot of code. And then about 2005, I got the bright idea that I would switch to data and analytics full time. And I had people who did data engineering and data science and data visualization working with me. And honestly, my life was not that great. I had small kids and things were breaking left and right. And, I'd go to soccer games and sit there and pipelines would break. I'd get calls or text and I'd have to leave and go fix things or marshal people to fix things. It wasn't pleasant. And, we had lots of customers, and it's nothing worse than deliver wrong data in the form of reports or data sets to 5,000 people, and then have the vice president call you up and say, if you do this again, you're out. It's just not a great feeling to give wrong data. And I had this sort of pit in my stomach every morning. Like I would come in and I'd be worried that something would go wrong in the production line. And I get this email saying, basically, you suck, the data is wrong again. And I had to brace myself every day for things that were going wrong. And I had the company I worked for did analytics for the US healthcare industry. And the US healthcare industry's got lots of notoriously complicated data. And as a result, it has a whole opportunity to create new insights from that data. And the boss that I worked for was a Harvard-educated doctor, and he knew a lot about healthcare and had a lot of great ideas. And he would come to me and say, "Hey, Chris, I've got this idea of how to analyze data." And I would sit down with a data engineer and a data scientist and maybe someone who knew Tableau. And we'd think about it and we'd say, "Okay, we think this is going to take us 2 weeks." And he'd sort of pull his glasses down and say, "Chris, I thought this should take 2 hours and not 2 weeks." And so, and lastly, I had hired just a bunch of smart people, and smart people like to use their favorite tool. They've got favorite tools to put data together. They've got favorite tools to visualize data, favorite tools to do data science. And, I just had a lot of conversations about, I want to do ELT versus ETL. I want to do R versus Python. And so after years of me complaining about this, my wife finally said, you got to fix this problem. And it's, I can't take you complaining about work anymore. So either quit your job or go ahead and fix the problem. And so in some ways, my journey of the last 15 years has been about solving these kinds of problems, which are, I'm going to talk about next. And so I've started the company, and I'm going to walk through kind of this idea of DataOps and what it is. And so I think one way to look at it is the core problem is of perception. Like, we've got a lot of data tasks that we have to do as a team. We've got to put data together. We've got to put an algorithm on top of it. We've got to visualize it. We've got to govern it. We've got to judge its quality. And this sort of river of work that's right in front of us. And that focus on the river of work has sort of blinded us to very large scale problems in data and analytics, i.e. that most projects in data and analytics fail. That most pipelines have too many errors, that most data science models never get into production. And so we're really focused on the task at hand, but there's these things upstream that are really problematic. And if you look at it from upstream, really what that means is about a how and not what. And the how is, how do you develop new work? How do you iterate quickly? How do you deploy things to production? How do you monitor and check it once it's in production? How do you test? How do you collaborate? And these hows are more people and process problems than they are doing the actual work. And so when 8 years ago we started the company, we ended up getting some customers, building a product, and 5 or 6 years ago we decided to bring it out to the market. And we found that no one really kind of got what we were talking about. So we had to put a name on it. And we wrote the first Wikipedia article, a manifesto, and we called it DataOps because some other people had been using it. And our other names were quite poor, like Agile Analytic Operations or DevOps for data science. And so if you could think about this, is that DataOps it's not about what you do. It's not about the model or the transformation. It's about how do you actually iterate? How do you take things from your mind as a data engineer or scientist and get it into the hands of your customers? And that cycle time of deployment, how fast you can experiment, is really about how well you learn. And then also, you run a factory to deliver analytics. And what's the error rate on that factory? Are your reports wrong? Are you late? And how much time are you spending in meetings? How collaborative is your team? And then finally, how do you measure and monitor results? And so we've taken that, called it DataOps, written some books. And so that's what this topic is about, to try to say, what is DataOps, how it's different than DevOps, how it's different than doing data and analytics. And so I'm going to go kind of into that right now to sort of talk about what that is. And so let's say we just start off with a really broad brush picture of people who do data and analytics. And so there are data engineers, and they maybe use a tool like Hivo or other tools to access data and integrate data and put it in a shape for analysis. And then there are kind of two groups of people who do the analysis. One is a data science team who takes the data and segments it, groups it, organizes it for an algorithm. And then there's perhaps a self-service team or a business analytic team who visualizes it. And then lastly, there's a data governance team who tries to keep track of it. And so if you just walk through the market, there's an $80 billion market in tools for each one of these people. There's sort of 50 data engineering tools, 50 data science tools, 50 visualization tools, and new ones are being created each day. And so our perspective, and if you walk through this, is that, like, let's just walk through an example to give our perspective. So first, a data engineer, they source data, and they have is a really simple example. They get this sales data with Joe and Kelly on. And then the data science team applies a cool algorithm to it. And you know what? They segment it. And Joe is low value and Kelly's high value. And then the self-service team gets at it. And maybe what they do is they mix in some data from Alteryx, they visualize it, and they add in this column. And then lastly, the poor data governance team tries to find out where it's from, where who added the data, where it came from, and that's called data cataloging or data lineage. And so all these people kind of work together. And in this idealized model, there's different groups of people, and oftentimes they overlap, but they generally work in teams. And another way to think of the process of doing data and analytics is these teams of people take data from lots of places, and CRM, ERP, supply chain, but they actually produce insight. And one of the things that we talk about in DataOps is the idea of a data factory, or every step that you do to integrate data, to build value from data. So accessing it, transforming it, running a data science model on it, visualizing it, governance, security, all those tools that are used to work and assemble the insight from the data. Think of them as workstations in a Toyota factory. And you're putting data together, you're adding value to it, you're putting artifacts like reports on top of it. And that is an assembly line. And so that assembly line itself, if you've ever run data and analytic teams, is problematic. Things break. And so that's one aspect. Think of what you do as an assembly line. And the funny thing about our assembly lines in data and analytics is they're not owned by one team. In a lot of organizations, there's a central data team who builds a data warehouse or a data lake or has a data enablement. There's a data science team who uses that data they have different names in different verticals. They're an AI team, they're a risk team. And in lines of business, there tends to be people who are focused on visualizing and giving information to customers. And this sort of hub and spoke model is hard. And there's lots of people who are involved in the manufacturing of data. And there's this rule of in engineering called Conway's Law that, ideally, when you build a technical system, it should be the interfaces on that system should be based on sort of logical structures of the system. And Conway's Law says, no, that actually turns out the way systems are built are actually reflect the organizational structure. And I think that's true in our data and analytics world. And that's not an ideal situation. And then lastly, one of the beliefs here is that I think the core belief in DataOps is that you need to deliver value to your customer. And that's the measure of success, not that you've done a task in a project list. It's that your customer has analytics that they're using and getting value from. And the second tenet of that, in some ways, is that you should do it in short iterations, that you should be able to give something to your customer, have them use it, and give you feedback. And that cycle, that iteration cycle, should be as quick as possible. And why does that matter? Well, you don't want to spend 6 months and giving your customer a very complicated system only to find out that you didn't get the right requirements. And so the idea of agility, the idea of short cycle times is really important in analytics, because the other thing I have learned is that analytic customers oftentimes don't quite know what they want. And they have to, if you give them something that's working, give them something that they can react to, you get a better work product at the end, and you end up doing less work. That's the magic of productivity, of iterative agile cycles, is that your productivity as a team goes up because you're doing less. You're giving the ratio of work that you've done that is valuable to the customer to unvalue is much higher. And the challenge here is we've got to do all these things on purpose. And Data Kitchen, we've talked about these two pipelines: the value pipeline, which is production, the innovation pipeline is in deployment. But you've got to be able to do these things simultaneously. You've got to run your Toyota-like factory, produce analytics with low error rates. You've got to be able to pick up a piece of that factory and change it so that you have a fast cycle time to iterate, to be agile, to get customer value. You've got to sort of hop over the fence to talk to each other in the Conway's Law world, when your data science team and your development team and your production team. And then lastly, one of the aspects, I think, of agility and certainly lean is a metric-driven way, and try to measure your team and measure the cycle time, your value pipeline, your innovation pipeline, your error rate. And so all these things kind of go in and talk about sort of what DataOps is and sort of where it fits in the world of data and analytics. So to sum up, what DataOps in some cases is used as a moniker to cover everything in data and analytics. And I don't think of that. You do DataOps on a data fabric or in a data management tool. And I think DataOps is a process-oriented methodology whose goal is to help teams deliver better value to the customer. And you do that through faster iteration cycles and focusing on low error rates in production, and do that through driving collaboration with your team and measuring the processes that you use to build and run things. So if I go to the next case and kind of talk about what I want to do here is kind of give a concrete example, sort of talk about what happens with some customers. And so to do that, I'm going to kind of go through and sort of talk about some pains that people have when they start wanting to do data ops. And, just to be concrete, I think all of us who've been in data analytics have heard some of these things like, hey, your data's wrong. Can you fix it? Or your team is just too slow. You're not getting enough done. Or I can't prove my team's got value. You can't measure your results or can't show your value. And so, and they all come in different forms. And so like, if we talk about from a people standpoint, that there's your data is wrong. Let's talk about what Eric feels, and Eric's the production engineer. And then we're going to talk about development data ops, which is Ahmed, who does deployment. And then we're going to talk about the manager, and we sort of bracket those up into sort of production and development and measuring data ops. But I think these quotes here are very common in data and analytic teams. Your data's wrong and your heart sinks, and you sort of get the wait for that email when you get in the morning, or your boss looks down your glasses saying you're too slow, or you just can't prove that your team's doing anything, right? Because it's hard you're not measuring the work output or the deployment output of your team. And so let's just talk about this case here of Eric. And so Eric is a production perfectionist, right? And everyone has a team where Eric exists. And so they're in charge of running the factory day in and day out. The data comes in, it goes through a manufacturing process, and reports and models and governance are put out, and they want to minimize errors. People like Eric are not about, they're about getting things right, and they want to make sure it's on time. And if there is a problem, they want to know where the problem is right away. And to do that, they sort of want a single pane of glass over their factory or factories. And so here's an example of an insurance company. And so it's a big American insurance company. They built this fantastic, what's called telematics. And so what that means is you put a beacon in your car, and that beacon sort of tweets out your lat long and your velocity and a time. And then a bunch of companies aggregate that data, and then that beacon then goes into the insurance company, and they look and they say, wow, this person is driving too fast or braking too fast. And that can end up affecting your insurance rates. And so, for some people, giving up privacy like that is anathema. For other people, it's a good way to get a discount. So depending upon your political perspective, I think that has one influence on this. But they built this really cool system that's event-driven. Things happen in Kafka. It goes into the cloud. It goes into Databricks to do ETL. There's some proprietary scoring and risk models. There's databases like Snowflake. There's a policy system, and then there's some applications. And so what happened is they built this, in the last couple of years, they built this really cool thing. It runs, it does great. It brings in from half a dozen different systems. It actually does the algorithm to score it. And the problem is that it runs fine. The challenge is they don't know whether the data that they're getting in it is good or whether things are running. So for instance, this is all a containerized application. Well, one container went down one day, and they started to get bad data. And the people who are using the applications and looking at it were saying it's wrong. Or sometimes the data providers would suddenly give data, and the car would jump 1,000 miles in 1 second. And of course, that can't happen, right? Or it would be incomplete. And so how do you then tell if it's the system is the problem or there's other problems? And the other challenge is that this was built kind of across lots of people. There were some people doing the event bus, some people doing the data science, some people doing the data warehouse. And so when things go wrong, kind of who do you call? And so the idea here is that if you could put something on top and kind of check the data, but also check the things that are being created from data. So as you're applying and interacting with the policy system, as you're checking the raw data itself and integrating it, can you get low errors and notify people when they're wrong, and perhaps even quarantine bad data? And so the idea of testing in production, or some people call it data observability, I think is really important, because pushing down low errors, and it's errors not only in data, but it's also in the data that you've integrated together and in the things that you've done on top of data, the reports and the models, and keeping track of it and notifying it. And so from a principle standpoint, in terms of production data ops, one of the things that we believe is that you should test your data in production automatically, kind of on top of your favorite tool, your favorite ETL tool, your favorite data science tool, your favorite BI tool. And if you find a problem in it, send alerts and notifications. And to do that, you've got to kind of keep track of history and make it easy for people to create tests. And there's a whole bunch of ways to think about checking data. Like one example is statistical process control. And a very simple example is day in and day out, you've gotten about 1 million rows every day from a data supplier. Well, it's Tuesday and you got 100,000 rows. And so that's something to be noticed, and that's something to be notified. And that's sort of a trend break. And so the idea here is, by focusing on error rates in production, you actually get more time to drive innovation, and you get more customer data trust. Because what happens when things go wrong is a lot of smart people in your organization are working nights and weekends to fix it. And so, yeah, errors happen in data, but you can build a system that can react to those errors and find them out before your customer sees them. And that's just less stress, less time to failure, and improves your customer data trust. So that's the first part of example I'd like to say. And so I think I see a question here. I can't see what it is. We'll have some time for questions at the end, I think. So the second is that if you think of how fast, so a tenet of any agile process in development or not, is that you can learn quickly from customer feedback. So that means driving iterations. That means deploying something quickly into production. And so a lot of organizations have challenges in deploying because they have lots of environments. They have a development environment and a system test environment and a pre-prod environment, a QA environment. And there's two aspects to it. One is sort of is there a railroad track that moves things from one environment to the other? Have you made it easy to pick things up? And there's deployment technologies like Jenkins to do it. But then there's the second is, can you actually have the signals on those railroad tracks to tell if you can move from one stage to the other without any problems? And I think that's really interesting. And a lot of data and analytics systems, you're doing your work as an individual. So I make a change in one piece. I make a change into some SQL. What's the impact of that change on the model or the visualization downstream? So how do you actually judge that? How do you properly regression test or do impact analysis in a development or a QA environment? And that's really the key here. It's not about moving things from place to place, because the sort of infrastructure as code and CI and CD process have solved it. Is how do you actually regression test? And so, the way to do that is actually decorate your whole system, use a lot of those same tests that you've done in production. And so automatically test, don't manually test in a development or a QA environment. And do what software engineers say, pull the pain forward. If you see as an individual contributor, you've made a change to a data transformation or a model, you should be able to see at your desktop whether there's a problem and whether that it works or not. And to be able to judge the impact across all your tools and all the subsequent work. And the idea here is that code-based unit tests, like I make up some fake test data, I run it through, it works. They're good, but they're insufficient. And so what this really means is you've got to test data to test your code. And so in development or in QA or pre-prod, you've got to pour in good test data into your data and analytics work and reuse a lot of those same production tests for what we think of as regressional or regression or functional tests. And by putting impact analysis in a QA environment, or i.e. checking regression tests, you actually improve the velocity of deployment. And you allow people to sort of remove their individual blinders, and it lowers the risk of change and less customers eye roll because you broke something. And so I think this is amenable to automation and amenable to being able to have automated testing, and a good way to do data ops. And so the third example I want to give is measuring data ops. And this is really How does a team leader understand how their team's doing? How do they look at errors across all their pipelines? How do you ensure you make your customers a success and prove your team's value? And in there, in short, there's sort of think of it as process analytics. There's a way to measure and get analytics about what you're doing. And so from that perspective, there's production metrics, like how many pipelines are in production? Are they on time? Are they coming up? There's data source metrics, being able to look at different data providers and see if they're good. And then there's project metrics, like how many tests are run and how many have I met my SLA? How many deploys am I doing? And so these metrics about the processes are actually really important. And I think of them from two ways. One is because if you've got these metrics, it's a way to show that your team is awesome as a manager. And then number two, you can use these metrics to help in troublesome circumstances. So for instance, that chart on the upper left, we call a tornado report. It actually shows problems by data source. And then you can use that to give leverage saying, hey, over the last month, you've given us crappy data sources 15 times and it's cost us this many hours of work. That's leverage. Or it's also being able to say that to people who are less than are skeptical of this data ops idea, saying that, yeah, you can go fast, you can deploy fast, and you cannot have a whole lot of errors. And by showing the relationship of tests to deploys to SLAs, I think you can do that. And lastly, there's a lot of more automation you can do with data ops. You can automate the build of your environment, right? To actually script it. You can automate the build. You can actually handle something called hub and spoke pipelines to be able to handle your self-service. You can handle different types of deployment pipelines. I'm a fan of more functional programming and functional deployments, and then just production pipelines. There's a lot of automation that you can do. You know, and a couple examples are really focused on automated testing and automated monitoring, but there is a whole lot of more automation you can do in data ops. And that's needed because like there is just a lot of tools out there. Like if you look at Azure or AWS or GCP, in the last 5 years, they've assembled everything that you can do in data and analytics, visualizations, data science, models, et cetera. And they've got databases and BI tools and DevOps tools. And so the complexity of all these tools is actually hard to do. And so, and to do that, I just want to talk about a little bit before I finish the role of the data ops engineer before I finish up. And I think this idea of automation is what the data ops engineer owns. And if you think of it this, the data ops engineer owns the assembly line. And they're trying to help people who do data engineering or data science or BI be successful. That's their customer. And in a lot of cases, does it mean that a data engineer takes their SQL and throws it over in a pod? What does done mean? How do you help these people get out of sort of willful blindness? How do you help them focus on their customer? How do you help them stop doing manual checks and do automation? And so for a lot of cases, what we think of the role of the data ops engineer is to build a system that takes these nuggets of work, ETL code, data science code, visualization code, put it into sort of pipelines, create tests, create deployments, run the factory, automate, work across people, measure success. And so in a lot of ways, what the role of the data ops engineer is to very simply take what's invisible and make it visible. And that has the net effect of helping productivity of your team. And so I'm going to skip these last ones and say, think of the last thing of the amount of work your team does in terms of data ops engineering. If you look at the average software engineering team, 28% of their time, actually in this statistic, 23% of their time is doing DevOps. And that's sort of making what's visible, working on the system, working on the how and not the what. And I think we should think about this idea of greater data ops engineering spending more time, up to 15% of the time. And so in the last few minutes here, I promised I'd go for 30 minutes. I just want to talk about what this all means and what the net effect is to end up. So imagine that you've got a graphic equalizer here on the left, and your cycle time of deployment from development to production is measured in weeks or months. Every other day you're having some significant error. You're spending a lot of time in meetings, and you don't really have an idea of what's going on. And the net effect of that, we think, is that team productivity is low and your customers are unhappy with what your team is doing. And we think if you go and do data ops, you can actually push up this graphic equalizer all at the same time. You can deploy faster and you can have less errors in production at the same time. They're not opposite. You can actually improve the collaboration and improve your process measurement. And if you do all those things, your team is actually more productive, and your customers are less unhappy. And I think what that means is that you actually are giving more insight to your customers, and that's the net goal here. And so in my final two slides, I want to say, we are Data Kitchen is a software company. We have a software platform that helps people do data ops, and helps people accomplish these goals of decreasing cycle time, lowering error rates in production, and improving collaboration and measurement. And so we have a great software product. I'd love to show it to you, but one of the things that we do is we've had to write a lot about what data ops is. So we've got 2 books that you can download for free. We wrote a manifesto. We've got a data ops certification video that you can go. And so if you go to our website, datakitchen.io, you'll find a lot of resources to get educated about what data ops is and to learn more. And so that is the end of my introduction to what is data ops. And so I think now we're going to actually go to questions. And so let's see, I'm going to go look and see. So there's one question here from the panelists. So, and it says, mine is more of a statement than a question. I've also seen that data customers need to understand their data better. Then no matter how solid our pipelines is, if there's not data understanding. And so I think, data lineage is also a true source of trying to understand problems. And so there's sort of 2 statements here. One is, yeah, I think data literacy and having your end business customer understand data is hugely important and not particularly addressed by data ops. Only in the sense of secondarily that you get better insight if you're more able to finely tune your result to what the customer wants. And instead of spending months or years delivering a first version, you can do that quickly. And so, yeah, I don't think data ops is really driving sort of data literacy or data understanding. I do think data understanding comes from, do I understand the end dashboard or do I understand the data behind it? And there's a lot of data governance solutions that, as I said, have sort of data catalogs and data lineage and that help you do that. And I do think those are also important in helping people understand where the data comes from. And so from a governance standpoint, one of the things that we talk about is in your typical helping people understand the data, there's sort of 2 parts in governance. One is, do I understand the data itself, its catalog? And do I understand where it came from, its lineage? But I think there's 2 other things that that we've seen. One is, can I trust the data? Not do I understand it, can I trust it? And then the other part is it on time? Is it fresh? And I think all those things I've seen analysts want out of data. Where did it come from? What is it? What does it mean? And then second, is it fresh and can I trust it? And I think data ops provides the latter. It helps understand, is it fresh and can I trust it through automated testing and through those metrics that we talk about. It doesn't so much help with, catalogs and catalogs and lineage. And happy to answer. That's the only question I see. I don't know if there's any other questions. Did I miss any?
Yeah, we have one more question. What are your suggestions and resources for the people to start DataOps culture within a data engineering team without using external tools and build these systems in-house? So what are your suggestions?
Well, I recommend that the first thing I did, and back in 2006 or 7, was I started with an Excel spreadsheet. And every time we had a problem in production or a problem deploying, we would make a row in that spreadsheet. And we were very religious about, and week in and week out, that spreadsheet filled up fast. And what we did is every 3 weeks, we sat down and said, look, let's try to look at all the problems and see if there's something common on them and pick one thing to automate away with scripting. And not blame people for it, not shame people for making a mistake, but hey, if the data was wrong or it was late, or it was on time, but something happened in the middle and we had to go through heroics, or and those things, those way of looking at your problems and building automation around it are at the core of the idea of DataOps, and you don't need a tool to do it. Because the secondary idea here in this is that a lot of data organizations get locked in more of a shame and blame culture, where the data team is shamed for doing things wrong and blamed for going late. And that causes the team to not want to look directly at their errors and sort of hide them. And I think making them public, putting a process to address them, and especially looking at common errors, because I was surprised back in 2006 and 7 how simple some of the solutions are, and how much, okay, let's write a one-page Python checker script, and that runs, and that saved us a lot of time. And so I think that's what one you can do right away without anything. And then the second, I think, is also I'm a big believer in version control, and you can download Git for free. Getting your data science models, getting your ETL or SQL code, getting your Viz code stored in Git, I think is a really important first step, because actually you just know, you know where things are.
We have one, maybe we can take one last question. So what are some of the top three problems that you've solved using DataOps?
Well, yeah, so I think, the first top problem is that we want end customers to trust the data. And so to do that, we've done automated testing in production to make sure that the raw data is correct, and also the integrations and the visualizations are correct. So it's testing and automation in production. And the second is that our belief is that delivering value to your customer is important. The best way to deliver value is in small chunks quickly. And so the rate at which you can take something from a development environment into production, the rate at which your cycle time of deployment. And DataOps helps that through both automation and sort of regression and impact analysis. And then the third is actually, I think, just as I spoke about, the third one is how to prove how to prove your team's doing well by measuring the work processes and the production processes that your team does. And all three of those actually have the net effect, finally, of driving your team to be more productive and driving your customers to have a higher chance of or higher success and satisfaction.
Okay, so thank you so much, Christopher. Thank you so much for sharing your insights and for making this a very, very interactive presentation. The audience have definitely learned a lot. I can see a lot of comments, and we all thank you so much for participating as a speaker.
I appreciate it. Thank you for the opportunity, and best of luck to everyone.